So this is Algebra on Topic 1, Lesson 1. It's actually one of the first things you're going to do this year. So what we need to make sure we understand is some of the prerequisites to this lesson, because if you don't know these things, then this lesson's not going to make very much sense for you. So you can open up your Google Doc and you may type along with me on the Google Doc if you would like. I know it's tough to click back and forth, but you'll see the things that I want. You can pause the video or pause this anytime you need to go back and forth. So here's what we need to know before we start. First, real numbers. Okay, all numbers are real numbers this year. So if I say a number, I want you to understand that it is a real number. Now, I can't say that real numbers are always going to be real numbers. That's why I wrote this year on there, because when you get to high school, you're going to learn some imaginary numbers, which obviously aren't real. But for right now and what we are doing, all numbers are real numbers. So if I tell you any number in the world, it's a real number. 0 is a real number. The square root of 137 is a real number. 5.8 is a real number. So understand that this is the easiest one to know because real numbers are all the numbers that we're going to learn this year. Okay, next up are rational numbers. So there's two types of numbers. We have a rational number and we have an irrational number. Here's what rational numbers are. Rational numbers can be written as a fraction. Okay, so any number I could take and write it as a fraction is a rational number. So here's what do I mean by that? Well, let's take the number 10. Can I write the number 10 as a fraction? I sure can. I can write 10 over 1 because 10 divided by 1 is still 10. It's a fraction. Can I take the number 4.8 and write it as a fraction? Sure I can. It's 4 8/10, and 4 8/10 simplifies to 4 4/5, and that's a fraction. It's actually a mixed number, but we could turn it into an improper fraction, right? So any number that can be written as a fraction is a rational number. You will also see this. It can be written as a fraction, and it will say in the form A over B. Guys, they're not trying to trick you with A over B. They just want to show you that that's the form A over B. So if you pick a number for A and you pick a number for B, and it will say B cannot equal 0. Okay, so I have to actually type that because I don't have the symbol for that. Cannot equal 0. Okay, the reason for that is because can you divide something into 0 parts? Not really, right? You can't do 5 divided by 0 because I can't cut something into 0 parts. So as long as B is not 0, it's a rational number. It's a fraction. B can't be 0. The bottom number is not allowed to be 0. Okay, so what are some examples of rational numbers? First example is a fraction. Well, no kidding, because we just said it can be written as a fraction. So if it's a fraction, it's automatically rational. So you could have the number 1/2. Okay, that's a fraction. That's rational. Whole numbers are also about fractions, which I know you guys already know. Fractions are just parts to whole. Okay, they're just a part to a whole. So if you have 1/2, then that just means we have two total parts, and one of those parts is being used up. A whole numbers start with 0 and go to infinity. And the reason I'm saying infinity is because of this. All whole numbers are 0. And then we could say 1 / 2, 3. And then I'm going to put 3 dots, which means it goes on forever. But 0 is included in that. Those are all the whole numbers. Whole numbers do not include fractions. So fractions are not whole numbers. They're pieces of numbers. So the whole numbers are 0, 1, 2, 3, 4, and we continue to go on to infinity in the positive direction. They also do not include decimals. So they do not include fractions and decimals. Okay? Natural numbers. Now, this is going to be weird because some math people say that 0 is not a natural number, and some math people say that 0 is a natural number. for our 8th grade school year, we are going to say that 0 is a natural number. So I'm going to be honest with you. I'm going to copy this. Whoops. I'm just going to copy this and I'm going to paste it because it is exactly it. However, we want you to know this. It starts with 0 and it goes on forever. And it's not, do not include the fractions and decimals. However, some teachers will say that 0 is not part of the natural numbers. The natural numbers are basically counting numbers. Okay, it's a little bit weird and confusing, but this year, whole numbers and natural numbers are both basically the same thing. They start with 0 and they go in the positive direction, no fractions, no decimals. Integers. Integers are positives and negatives, whole numbers. Okay, so again, if they're whole numbers, that means they can't be fractions and or decimals. Okay, so it's positives and negatives. So the only thing, the big deal with integers is still whole numbers, but some are positive, some are negative. We still consider them to be an integer. So the number 5 is an integer. The number 5 is also a whole number. The number 5 is also a rational number. The number 5 is also a real number. So there's all kinds of things. It's not just specifically towards one thing. Okay, perfect squares. Perfect squares are when we have something like this. 1 times 1 equals 1. That means 1 is a perfect square because there is a number multiplied by itself that gives you an answer. Okay, so 2 times 2 equals 4. 4 is the perfect square. So the number 1 is a perfect square. I'm just going to highlight that. The number 4 is a perfect square. Okay, I'm going to highlight that. What would be the next perfect square? The next perfect square would be 3 times 3, which would be equal to 9. You get the picture. So perfect squares are the numbers like 1, 4, 9, 16, 25. You'll be able to name them all. There's a reason we need to know perfect squares, and we'll explain that more later. Okay, irrational numbers are the other category that you were going to see a lot in 8th grade. Irrational numbers are numbers that are non-repeating. Actually, I'm not going to rate numbers. I'm sorry if you're typing along with me, guys. I apologize. I'm new at this too. Decimals that are non-repeating, so they don't repeat. Non-terminating, which means they never stop. Okay, and they will never ever stop. So, for example, we have the number pi. This symbol right here is the pi symbol. Pi, we are represented as 3.14. Okay, but if we used a calculator and we wanted to know what 3.14 was, well, pi was, it would keep running on forever and ever, and there's all these numbers that go with it. And it never stops. And the reason it never stops is because it's irrational, which means that's the reason we can't write it as a fraction, because we can't put it over 1 because we don't know where it's going to stop, because it's not going to stop. It's never, ever going to stop. So pi is one of those things. The other things are numbers that are not perfect squares. So let's say we have the square root of 81. Well, the square root of 81 is equal to 9, because 9 times 9 is 81. But let's say we went to square root of 82. Well, square root of 82, we don't have a perfect square, because a number of times itself is not going to give you 82. So it's not a perfect square. So therefore, any radical that's not a perfect square, any square root that's not a perfect square, is irrational. That decimal will continue to go on forever. It will never stop. Therefore, we can't put it over 1 and call it a fraction. So the two biggest things you need to know about irrational numbers, they're non-terminating, non-repeating decimals. They will never stop, which means we can never write them as a fraction. Those are the most important ones that you'll need to know for this lesson prior to this lesson. Please keep those in mind. You're going to need them all your entire school year. So don't give up on them.